by mistakenly video has paused in point number 3. I continue for later. Okay, so similarity with halogens. We just discussed that in some compound hydrogen shows +1 oxidation state, and in some various compounds hydrogen shows -1 oxidation state, like halogens, like NaH, lithium, LiH. These are called hydrides, metal hydrides. Okay, so these are the similarities with halogens. Next point, non-metallic nature. Hydrogen is not metallic in nature like alkali metals. You see, this is non-metallic in nature like halogens. Point number 5, existence in the form of diatomic molecules. Hydrogen form elemental state, it exists as H2. Similarly, halogens like chlorine, fluorine, bromine, these also exist in diatomic molecular form. Okay, so hydrogen have dual character like alkali metals and like halogens. Okay, but in the new form of modern periodic table, hydrogen is placed in group 1 as its electronic configuration is 1s1, and the total elements are placed in periodic table according to their electronic configuration. Okay, next portion that we are going to discuss, that is preparation of hydrogen, preparation of dihydrogen. You all know we can prepare hydrogen from water, from acids, from bases also. First we discuss from water. From water we can get hydrogen in different manner. Firstly, cold water. Cold water means some highly reactive metals. Highly reactive metals means the top of the chemical series, electrochemical series, that are above the element hydrogen. So highly reactive metals according to electrochemical series reacts with cold water and form dihydrogen. But here in this example you see that amalgamated sodium. Why sodium amalgam is used? As you all know, sodium catches fire in presence of H2, so we use sodium amalgam. Okay, next, with hot water or steam, some reactive metals that are not like highly reactive like sodium, potassium, but they are reactive metals like zinc, iron, these reacts with hot water or steam and form dihydrogen. Zinc reacts with hot water from zinc oxide and hydrogen gas. Then you learn the most important industrial preparation of hydrogen. In case of industrial preparation of hydrogen, this Lenz process is used. What is this Lenz process? In this Lenz process, iron in presence of steam, it formed dihydrogen and ferrosulfuric oxide. So this is the industrial preparation of hydrogen. Okay, next, carbon. As although carbon is non-metal, but carbon react with hot water or steam and form carbon monoxide and dihydrogen. This mixture of dihydrogen and carbon monoxide mixture is known as water gas. Students, you must remember that 1:1 ratio of carbon monoxide and hydrogen is known as water gas, but any ratio in any mixture of carbon monoxide and hydrogen is known as syngas. Okay, so from cold water, next hot water. Next preparation method by action of water on ionic hydrides. Ionic hydrides Previously you see that sodium hydride, lithium hydride, potassium hydrides, all are ionic hydrides. These ionic hydrides reacts with water and form dihydrogen. Like that, sodium hydride react with water from sodium hydroxide and hydrogen. Lithium hydride also from lithium hydroxide and hydrogen. See this important hydride, hydrolith, CaH2, calcium hydride. This is known as hydrolith. This hydrolith react with water and form calcium hydroxide and dihydrogen. Okay, so by the action of water on ionic hydrides, we also get dihydrogen. Okay, next, reaction of water, that is steam, with methane. By the reaction of methane with steam also we can get hydrogen. In case of reaction of methane and hydrogen, we get carbon monoxide and hydrogen, and this mixture of carbon monoxide and hydrogen is known as water gas. Remember that 1:1 mixture, but if the mixture is in any ratio, this is called syngas. Next, by electrolysis of water. By electrolysis of water, you all know, in case of electrolysis of water, as water is non-electrolyte, we must add some acid or some base or some salt to electrolyze it. Okay, water in presence of like H2SO4 acid, it form H plus and OH minus, and this H plus ion goes to the cathode and gain 2 electron to form dihydrogen. So by electrolysis of water, we also get hydrogen. Similarly, water in presence of base potassium hydroxide, it electrolyze and go from H plus ion. This H plus ion go to cathode and gain 2 electron to form hydrogen. Last method, from acid. Last, not second. Second, we get hydrogen from acid also. Like magnesium, zinc, this type of metal reacts with diluted acids and form hydrogen gas. Similarly, you see that magnesium reacts with HCl from magnesium chloride and hydrogen. Zinc reacts with dilute H2SO4 from zinc sulfate and H2. Remember that this is the laboratory preparation of hydrogen. This is the laboratory preparation of hydrogen. Zinc reacts with dilute H2SO4 from zinc sulfate and H2. This is the laboratory preparation of hydrogen. Remember that dilute H2SO4 must use, not concentrated H2SO4. Why not concentrated H2SO4? As concentrated H2SO4 is an oxidizing agent. It's oxidized. Okay. So in case of formation of laboratory preparation of hydrogen, we use zinc with dilute sulfuric acid from zinc sulfate and hydrogen. Last of today's class, preparation of hydrogen from alkalis. Zinc react with sodium hydroxide from hydrogen and sodium zincate, Na2ZnO2. Also sodium hydroxide reacts with aluminium from hydrogen. In that case, it's from sodium aluminate. Okay, so zinc react with sodium hydroxide from hydrogen gas and sodium zincate. Okay, bye bye students. This is up to your today's lesson. We will meet in the next class.